Let's practice graphing a cotangent function together. If you'd like to download a free copy of this blank PDF or the answer key PDF, you can find a link to that in the description box below. Let's get started. The function that we're going to have here is f of x is equal to 1/2 times cotangent of 2x. This is the formula that we're going to use to figure out what are the types of transformations we're going to have on this function. So going ahead and figuring out all the different pieces here, we're going to have f of x is equal to, I think a is going to be 1/2, that's that coefficient out in front, times cotangent, that's just our trig function. Now b here is going to be 2, that's going to be 2 multiplied by x minus what? I think it's just going to be 0, I think c is 0 here. And then finally we're going to go ahead and add d, and d's value here is going to be 0. And so let's go ahead and write that down. A is 1/2, B is 2, C is 0, and D is 0. Now the effect of this 1/2 for A is just going to change the shape of the graph just a little bit, cause it to stretch or shrink. This B value of 2 is going to affect the period. C lets us know if we are going to move left or right, but we are not going to in this case because C is 0. And D lets us know if we're going to shift the function up or down, but in this case we're not going to again because D is equal to 0. Now that we know a, b, c, and d, let's go ahead and see what the parent function would look like. The parent function would be f of x is equal to cotangent of x. And so if we go ahead and find cotangent of 0 radians, pi over 4 radians, pi over 2, 3 pi over 4, and pi, which is all located on the unit circle, you want to remember that tangent of theta is always equal to the ratio of y over x. So cotangent, being the reciprocal function, is going to be the ratio of each of these x's divided by the y coordinates at each of these radian measures. At 0 radians, we're going to have the x and y value of 1 and 0. So 1 divided by 0 is undefined, so that's going to be undefined at 0 radians. At pi over 4, or 45 degrees, that x value and y value are both going to be root 2 over 2 divided by root 2 over 2, so that's just equal to 1. At pi over 2, or 90 degrees, the ratio of x to y is going to be 0 over 1, which is equal to 0. 3 pi over 4 is 135 degrees, and at that location, the x value is just negative root 2 over 2, and the y value is positive root 2 over 2, so dividing those, we're going to get negative 1. And then finally, at pi, or 180 degrees, the x value and y value of the coordinates there are going to be negative 1 divided by 0, and that's going to be undefined. So given each of these x values, or angle measures, we're going to get each of these y values that go with them. So we're going to be able to put a table together. Putting all these corresponding x and y values in a table, this is what we're going to get for a table for the cotangent parent function. So while this table right over here is for f of x equals cotangent of x, let's see if we can start making a table for the actual function we're doing, which is f of x is equal to 1/2 times cotangent of 2x. Now we said earlier that this b value of 2 was going to affect the period, which it will. So try to remember our period formula, which is just going to be for tangent and cotangent, that's just going to be pi divided by b. In this case, we have b equals 2, so pi divided by 2, or pi over 2, that's going to be our period for this function. So let's go ahead now and take this original table we had for the parent function, and let's make some changes to it. Let's go ahead and get rid of this pi over 4, pi over 2, 3 pi over 4, and pi, because we're going to have some new values there instead. What we're going to replace them with, though, is going to be this pi over 2 at the very end, since that's going to be our period. We said our period was pi over 2, so we're going to start at 0, and we're going to end at this pi over 2, so that's how long it takes to make one cycle here. And we have to go halfway between those. So halfway between those, half is going to be pi over 4. Okay, and then half of that is going to be then pi over 8, and if we add half of whatever that is in the other direction, that is going to be 3 pi over 8. Now we don't need to move any of our x values to the left or right, or any of the y values up and down, because c and d happen to be 0 here. If you'd like to see that in another video, we can go ahead and do that. So we just have to use this 1/2 now, and this is going to stretch or shrink the y values. Okay, so if we take a look at the y values here, or f of x values, we're not going to be able to stretch or shrink the asymptotes. We're going to leave these two undefined values alone. But if we go ahead and multiply 1/2 by 1, that's going to become positive 1/2. 0 multiplied by 1/2, now that's going to stay the same technically here. And then this negative 1 multiplied 1/2 is going to be negative 1/2. So these are going to be the new y values. So putting this all together, we're going to have 0, and then we're going to have pi over 8, pi over 4, 3 pi over 8, and then pi over 2. That's going to be all of our x values. And then our y values here are going to be 1/2, and then 0, and then -1/2. So now that we have some ordered pairs that we can plot on our graph, let's go ahead and graph this cotangent function. All right, let's take a look at this graph below. And here's the table we just found out off to the side. Here are all the radians along the x-axis, and here are the y values or the ratios along the y-axis. We have a vertical asymptote at x equals 0, and because our period here is pi over 2, it's going to repeat every pi over 2. Here you can see we can actually fit 4 periods of this graph on here. Graphing this pi over 8 comma 1/2, that's going to be right about here. Then for this pi over 4 comma 0, that's going to be right on the x-axis, that's going to be here. And then finally, we have this 3 pi over 8 comma -1/2, and that's going to be right here. Making a rough sketch through these 3 points, this is what our cotangent graph would look like for one period. And so because these functions are cyclical, we can sketch it again over here, and here, and here. And so there you have how to graph a cotangent function given a couple of transformations. For this particular case, we just had a little bit of stretch and shrink being applied to the cotangent function, as well as a period change as well. So hopefully this video helped you grasp how to imagine what the graph would look like, as well as come up with where the parent function comes from, and then how to apply that to the transformations. If you found this video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.